HBK offer for motor durability testing. So we have the eDrive product, which is a data acquisition system, very accurate. We have sensors, which are very accurate, and we have some software for visualization. We offer a continuous collection of electric and mechanical signals. So you time align can have your temperatures, your CAN bus, your voltage, your current, your vibration, all in one place, your torque, your speed, so that you can understand how is my inverter affecting my torque ripple? How is my inverter affecting my temperature? And then note the changes between that. We have a really low measurement uncertainty, which means that when you do get a measurement like current, you can trust that within a pretty tight band. So if you have deviations from that, you can really note them and trust them. If you have a deviation in efficiency, you have a deviation in power, having a low measurement uncertainty will let you trust big changes. So that if it is a 2% or a 3% change you're looking for, you can trust that measurement. We have a live view of calculated values. I missed a couple letters in there, apologies. Where you can program in, these things like negative d-axis current, these zero sequence voltages, these harmonics, and you can track those and watch them live and watch if they're creeping and record that as data. If you're running a test for 80 days and you're measuring a 10 kilohertz inverter, that's a lot of data. We have some really cool data reduction techniques and triggering techniques so that you can do these long-term tests and still catch those really short events. So you can have your really long data stream trigger, have high frequency events, and really see how that inverter is functioning during some of these faults. We have feedback to control systems, so you can feedback to your dyno, your power hardware in the loop, however you're testing. And we're really proud of our local support and training so that if you're trying to do some mad scientist stuff, we can absolutely help you get there. So we got accuracy, we got data, we got electromechanical. Let's look at some examples of how this system could be used for durability testing. So I'm going to start with extended testing and data reduction. So this example on the right-hand side is actually a 5-day test where we were looking at temperatures and harmonics. And by using some of those data reduction techniques where we were averaging total harmonic distortion over maybe at like a 20 hertz rate, we can record for days, and that creates almost no data compared to looking at megahertz data. So we can use the megahertz data to do things like a harmonic distortion calculation, store that harmonic distortion, throw that high-speed data out, and record for days on end. And then if we see a trigger, we could take that mega sample data, and you can have both the long-term test and the event of failure. So eDrive is really good for recording for long periods of time what you might be experiencing with many of your durability tests. We are electromechanical, and this doesn't show up as good as I hoped. I'm sorry about that, but we will record your high frequency inverter at a high enough rate where you can understand all those PWM switches. We'll then record the current at that high rate so you can see the current harmonics and start to tie that back to maybe torque ripple or vibration. We record the torque at up to 6 kilohertz, and if you have a higher bandwidth torque sensor, we could record at a higher rate as well. But you can get that torque disturbance and understand both the amplitude and the frequency of that torque ripple. And then we can translate that to vibrations on the shaft, vibrations on the housing, and record all of those in one place. So eDrive can measure the full system for correlation, electric and mechanical. You can start going into some deep data processing to understand all of these signals. We can do a lot of nerd stuff, and I shouldn't call it nerd stuff, but we can monitor the DQ0 for motor state. We can look at the zero sequence for faults. We can do a flux estimation. We can do real-time calculations of harmonic and harmonic phases. You can understand what the third harmonic of the zero sequence voltage is and view that as a scope trace. We can do harmonic power calculations if you think that an increase in your harmonic power losses will be indicative of failure. And we can feed all of this back to control systems. So, up here I've got my DQ0, my D-axis currents, my D-axis voltages, my fluxes, my harmonics. This is all to say, if your FEA guys, if your CAE guys have said, I think my failure modes are going to be at a certain flux level and we're going to see an increase in the harmonics, you can plug those in and you can have those monitoring live. You can trigger on those values. You can watch those values and see if they exceed a threshold. The eDrive system allows live advanced analysis and monitoring so that you can trigger on all these values. So that's some exciting stuff. If you're working closely with your CAE, your FEA team, you can have a really good conversation about how do we monitor for turn-to-turn faults? How do we monitor for demagnetization? We have a really cool measurement uncertainty tool so that you can understand, can I trust my measurements? From the measurement side, you plug in your voltage level, current level, frequency, and we give you, you can trust plus or minus 3 watts. You can trust plus or minus 4 watts. We have a nice tool that lets you know this is the band I can trust. So if you're looking at tolerances, you can account for that trust level in your tolerances. And this is where it comes to trusting your measurements. So eDrive lets you trust your electrical measurements for power, for voltage, for current. And we have a nice tool to help you do that. This is our measurement uncertainty calculator. And for anybody out there who's familiar with ENCODE GlyphWorks, HBK has both the ENCODE product and the eDrive product, and we work very nicely together. ENCODE is a trusted partner in durability for many applications. You know, GlyphWorks lets you display the data, perform detailed analysis, run what-if scenarios, and do it very quickly. You know, they're very good at data management. They're very good at processing large amounts of data, you know, that day's worth of data. And they can augment raw data with performance indicators and compare different configurations. And we have a really nice webinar on why electrification engineers choose ENCODE GlyphWorks. I advise all of you to go watch it. Fred Kim is fantastic. But you can take these datas offline and do all those analyses that I frankly don't understand all that well. But you have the tools to do it and correlate to different fatigue methods. So HBK is really a full solution provider. I work very closely with those teams and I enjoy working with them. All right, let's look at an example. I promised everybody you'll see why